In our vitamins video, we spoke about how nutrients regulate just about every single molecule in our body, from how our genes function to how every single cell is created. Minerals and elements also have many overarching functions in the body. The difference tends to be that most minerals and elements don't directly regulate the genes in our body. They tend to be precursors and have functions in cells and cell materials. You might have noticed a number amount next to the mineral or element. This is actually how much of it occurs in our body. So yesterday we did a video on electrolytes, and a lot of people were saying that they needed to supplement potassium, magnesium, and sodium. But the reality is, when you look at the amount of these things that our body stores, what we've been told we need to take, by the USDA, by the dietary guidelines, it seems to be a bit inaccurate. At least that's what the physiology of our body is telling us. Sodium is needed for the maintenance of the positive and negative charge of cell membranes. Sodium is negative and potassium is positive. This involves nerve impulse transmission, muscle contraction, heart function, letting metabolites and nutrients in and out of cells. So, at face value, sodium doesn't seem as important as directly regulating a gene, but metabolites and nutrients in and out of cells is literally every single cell in our body. Blood volume is regulated by the body adjusting its sodium content. So when you have low sodium, aldosterone is released, and that releases potassium out of the body. Sodium restriction can actually increase your blood lipids, your cholesterol, and increasing sodium improves glucose tolerance as well as insulin resistance. Sodium is also important for absorbing chloride in the stomach, amino acids, glucose, as well as water. So when you're supplementing potassium, you can deplete your sodium and your body will actually release even more potassium. So you got to be very careful with the electrolyte mixes if you're using them. And sodium occurs in a pretty wide range in our body. I've seen numbers indicating 92 grams to 200 grams. So this leads me to believe that sodium is very subjective, and different people have individual tolerances and needs for salt in their diet. You have the First Nation Alaskans that didn't salt their food at all and ate a lot of fish. And then you have groups of people in the 17th and 18th century that literally ate dozens of grams of salt per day in the form of salted fish. Moving on to potassium, the amount of potassium in the body is 120 grams, and you would think it would be multiple times the amount of sodium from what we've been told, but not the case. Potassium is the fluid inside of cells, and its main function is actually for carbohydrate metabolizing enzymes. This is why plant foods have potassium. Your body needs potassium to utilize and digest some carbohydrate nutrients. But outside of that, potassium doesn't have an incredible amount of functions in the body outside of this, the maintenance of the positive and negative charge of membranes. So there's a lot of tie-ins here between potassium and sodium. Calcium is the most abundant mineral in our body. It comprises 1% to 2% of our body weight. It is very antagonistic with zinc, iron, and magnesium. So when you consume too much calcium, you can deplete these other minerals and elements. Its main function, as most people know, is the formation of bones and teeth. This includes the remodeling of these tissues throughout the life, as well as during developmental stages and forming them. It's also important for intracellular messaging and nerve impulse transmission. This is actually what EMF radiation disrupts. Things from cell towers and Wi-Fi signals. It messes up the calcium metabolism in our bodies. But I've done much more in-depth videos on calcium. One is titled Calcium is Dangerous. One is How to Reverse Calcification. So if you do want to learn more about calcium, I will link those videos at the end here. Compared to what we've just spoken about, magnesium has a lot more functions. The body stores 22 grams to 26 grams of magnesium. So when people are taking like 300 grams of magnesium glycinate, that doesn't really make sense to me. When you take calcium, as we said, it can deplete magnesium, and taking too much magnesium can actually deplete your potassium. It is needed for over 300 plus enzymes in the body. Enzymes are proteins that perform different functions. It could be a digestive enzyme, it could be an enzyme that releases fat when it gets to a certain part in your body. Genes and enzymes are essentially how our bodies function on a molecular level, and that's the most complicated form of nutrition you can really understand. Once you understand the types of enzymes, the types of genes involved in certain processes, there's nothing more you can look into. It's involved in protein synthesis. So for example, you could figure out which enzymes magnesium is involved with in protein synthesis, and there would probably be dozens of them. It's also needed for muscle contraction, nerve function, blood glucose control, hormone receptor binding, blood pressure regulation. Magnesium plays a large role in energy metabolism, specifically the energy conversion of carbohydrates and fat. It is needed for ATP, molecule and energy production. It is involved in oxidative phosphorylation, which is energy production in the mitochondria of the cell. So every cell in our body needs magnesium for energy, as well as glycolysis, another energy process in the body. Magnesium is also needed to create nucleic acids, which are DNA and RNA cell precursor materials. It is involved in the transport of potassium and calcium across cell membranes, therefore plays a role in cell signaling, and it is needed in every single vitamin D3 metabolizing enzyme. So all of the enzymes associated with absorbing vitamin D3 require magnesium. It's also needed to absorb certain B vitamins and is involved in glutathione, the chief antioxidant production. Phosphorus is also another very abundant mineral, one of the most common ones. It works with calcium to form bones and is also part of the structural framework of DNA and RNA, which means it is needed in every cell in the body to transport energy. But the chief function of phosphorus is the growth, maintenance, and repair of cells and tissues. So moving on to sulfur. Sulfur is contained in amino acids, therefore is an integral part of their structure. We obtain sulfur in our diets from the amino acids methionine and cysteine. The main function of sulfur is in glutathione. Again, glutathione is the chief antioxidant in the body, very important for detoxing, immune system health, as well as eliminating oxidative stress. Sulfur is also involved to some degree in helping our bodies absorb protein and the production of prostaglandins. There isn't really a lot of information known about prostaglandins outside of them being inflammatory mediators and literally being present in every single cell in our bodies. To some degree, prostaglandins have gotten the cholesterol treatment where if something is present where there is inflammation, it's looked at as a bad thing. Chloride is mainly obtained by consuming salt. Salt is simply sodium bound to a chloride molecule with a bunch of other trace minerals and elements. It is involved in fluoride balance, and chloride is one of the main components of gastric juice. Moving on to the elements, first we have iron, and there are 4 grams of iron in our bodies. Iron is chiefly for the transport and storage of oxygen. That's why 70% of it is contained in the hemoglobin of our blood cells. Iron is also important for cognitive development and function and cell division. This is why, we see vegans out of breath, lacking mental function. They need iron. There are 2 enzymes in the body, catalase and peroxidase, that contain and require heme iron, and these reduce oxidative stress. So if your body isn't absorbing iron properly or metabolizing it how it should, that's why excess iron in the diet can cause free radical damage, and that's why people associate heme iron with cancer. And the answer to this is that iron requires copper to be absorbed, it lowers your zinc absorption, calcium intake lowers iron absorption, and you need vitamin A to absorb iron as well. Some people say that vitamin C increases iron absorption, but it's very marginal compared to these other things. And it's very easy to see how if you don't have all your vitamins, minerals, and elements in balance, how iron isn't going to be absorbed properly. So the big issue is, modern processed foods, don't contain the nutrients we need to assimilate iron properly. Next up is zinc, and there are 2 to 3 grams of zinc in our body. It is the direct antagonist to copper, and as we mentioned earlier, high calcium intake can lower zinc absorption. Zinc, just like magnesium, is involved in 300 plus enzymes in the body. It is a crucial component of vitamin A, and it is needed to transport vitamin A. So regardless of how much retinol vitamin A you consume, if you don't have adequate zinc in your diet, your body isn't going to utilize it. These enzymes entail growth and development, immune response, neurological function, reproduction, learning ability, as well as certain nervous system activities. Zinc actually directly regulates gene expression. It is also a component of the structures of the proteins and the membranes. And this means that zinc is involved in cellular growth, development, and signaling. Copper is in 1.2 to 2.1 milligram per kilogram of body weight. And the ratio between zinc to copper is supposed to be between 8 and 15 to 1. So if you look at the amount of zinc that's being stored in your body versus the amount of copper that's being stored in your body, it is about 8 to 1. Copper is required for the aerobic respiration of all eukaryotic cells because copper is an oxidant, and you need copper to oxidize nutrients and release energy in the cell. Therefore, copper is needed for the growth and development of every single tissue in the body. Zinc to copper ratio is incredibly important. I might do a whole video on this, but if you're someone who's consuming a lot of liver, you might not be getting enough zinc to counteract that. So you need to be consuming high zinc foods if you're consuming a lot of liver, which is very high in copper. Manganese is a component of dozens of proteins and enzymes, and is also a coenzyme in macronutrient metabolism, which means it is involved in energy production. It is critical for bone formation, free radical defense, development, digestion, reproduction, as well as immune system health. This is an element that's obtained in small amounts in just about every animal food we consume. Fluoride, unlike everything else we've spoken about today, doesn't seem to have anything positive. Fluoride damages your thyroid. It can cause the bone disease fluorosis. And the only thing I can speculate is that fluoride might play a role in calcium metabolism in the teeth. But there's 2 forms of fluoride. Calcium fluoride, which naturally occurs and our body doesn't really absorb it. And then there's sodium fluoride, which is what we artificially add to water, and that is what damages our health. So out of everything we've spoken about today, ditch the fluoride. Iodine is crucial for thyroid function, and it has anti-cystic as well as anti-cancer properties. I have a whole video explaining iodine, the importance of iodine, how to obtain it, so I will link that at the end here as well. And so I'm going to link you guys, the video on calcium, I'll link you guys the video on iodine, and you can also check out the video I did last week on why vitamins are important. Hopefully I've given you guys a fairly brief understanding of the overarching functions of these minerals and elements and why they are important. The main thing to take away from this video, some of you guys might have known a lot of these things, is the ratios of these minerals and elements in the body. And stop worrying about getting incredibly high amounts of all the nutrients, because everything has a U-shaped curve. The body can only utilize so many minerals, so many elements in its health. So thank you guys for joining me today.